Hi dear, this is Dr. Malai Saambassivame. So I am going to discuss about Laplace transforms, initial value theorem and final value theorem. First let us start with the initial value theorem. Initial value theorem. Statement is if L of f of t equal to f of s, capital F of s, which is nothing but the integral 0 to infinity f of t into e power minus st dt. Then limit t tends to 0 f of t is equal to limit s tends to infinity s into f of s. So this is the statement of initial value theorem. Now we will discuss how to prove this. Proof. By derivative of Laplace transformation, we know that Laplace transforms of f dash of t is equal to s into Laplace transform of f of t minus f of 0. That is nothing but s into f of s minus f of 0. By statement Laplace transform of f of t equal to capital F of s. So from this let us take limit. Taking limits as s tends to infinity on both sides, we have limit s tends to infinity of s into f of s minus f of 0. That is, I am starting with the right hand side. That is equal to limit s tends to infinity L of f dash of t. By applying limit to both the terms of the left hand side, we get the limit s tends to infinity s into f of s minus limit s tends to infinity f of 0 is equal to limit s tends to infinity. We will write the value of L of f dash of t. By definition, it is integral 0 to infinity f dash of t into e power minus st into dt, which is nothing but 0 as e power minus infinity equal to 0. When we substitute s equal to infinity, this becomes 0, therefore the whole integral becomes 0. So from this what we get is left hand side is limit s tends to infinity s into f of s minus when you substitute this limit s tends to infinity f of 0, there is no variable here, so definitely we will be getting just f of 0, because only s is tends to infinity, there is no s here. So 0. This f of 0 can be written in other way as, this is written as limit t tends to 0 f of t. When t tends to 0, f of t is nothing but f of 0. Therefore f of 0 is written in this way. So this gives the required proof. Limit t tends to 0 f of t is equal to limit s tends to infinity s into f of s. So this is the proof for initial value theorem. And now we go for final value theorem. So first let me give the statement of final value theorem. Final value theorem. Statement is, if L of f of t is equal to f of s, which is nothing but integral 0 to infinity f of t into e power minus st dt, then limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s. This is the statement of final value theorem. Now to prove this, we will use the proof like initial value theorem. So let me start with the same result, that is the derivative of Laplace transform results. So that is L of f dash of t is equal to s into L of f of t minus f of 0. This is the result, which is written as s into capital F of s minus f of 0 by the statement. So taking limit taking limits as s tends to 0 on both sides, we get a limit s tends to 0 s into f of s minus f of 0 is equal to limit s tends to 0 Laplace transformation of f dash of t, that is equal to limit s tends to 0. The value of L of f dash of t, by definition it is integral 0 to infinity f dash of t into e to the power minus st dt. Whereas the left hand side, it is limit s tends to 0 s into f of s minus limit s tends to 0 f of 0. Now we will simplify both the left side and right side. we get the first term, the left side is limit s tends to 0 s into f of s minus, so this is nothing but f of 0, because the limit is given to the variable s tends to 0, f of 0, so automatically it is f of 0. And the right side is we get a integral 0 to infinity f dash of t into dt as limit s tends to 0 e power minus st is equal to e power 0, that is equal to 1. So that is why I am leaving that, which is nothing but integral of differentiation of f of t. So integral symbol is also there, differentiation symbol is also there. So what we get is f of t under the limits 0 and infinity. By substituting upper and lower limits, we get f of infinity minus f of 0. This f of infinity can also be written as limit t tends to infinity f of t minus f of 0. I have written this f of infinity as this, whereas the left side we get the limit s tends to 0 s into f of s minus f of 0. Now we get f of 0 on both sides with the same sign, so we can remove them. Then remaining what we will get is limit s tends to 0 s into f of s is equal to limit t tends to infinity f of t. This can also be written by interchanging the terms, limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. So this is the proof for final value theorem. So thank you for watching. So we will discuss some other topic in some other video.